So have a look at the questions. You can ask me whatever you wishes.
Okay, wait. It's showing you a new thing in question 7, and it's giving you the formula like the sector area and the arc length.
Okay. So that the theta in radians. Okay. So using this, what we are going to discuss now, we are going to find out, or we are going to discuss area of a sector and length of an arc. Length of an arc. We will discuss length of arc first. Length of arc. You see here, what we do, at first we draw a circle. Here is our circle. We locate the center of this circle at first. Here is the center. Suppose there are 2 points lying anywhere on the circumference of circle. These are the 2 points, A and B. At these 2 points, if I join these 2 points at center, then this whole region, which is confined between this black line and these 2 red lines, is called a sector, and the distance along with the circumference from one point along with the circumference from one point on A, this distance, this to this is called length of an arc. This is called length of an arc. Okay, we need to find this distance. We represent this distance by L, from this to this. Okay.
Yeah.
So my dear, you tell me one thing. If I start moving from point A along with the circumference of this circle like this, I hope you can see the cursor, and I move until I again reach the same point A. Look, listen what I'm saying. I'm starting my journey from A. I'm moving along with the circumference of circle along with this black line, and I reach at point A. Then what is the distance traveled? Distance traveled from A to A.
Like,
A to A. This is what?
the
This
circumference
is
of the
the
circle.
circumference of circle. And what is this formula for circumference of circle? It's 2 pi r. It's simple.
Yeah, 2 pi r.
2 pi r. And tell me, if I start moving from A, and I reach at point A, how much angle did I make?
360.
360 degree. So if I travel 360 degree angle, we cover a distance that is equals to 2 pi r. For 1 degree angle, we will cover a distance that is equals to 2 pi r upon 360. What I am doing, I just assume that if I reach from A to B, then I have traveled an angle theta. So for theta degree angle, distance traveled along with the circumference is 2 pi r theta upon 360. And the distance that I have traveled for getting this angle theta is distance from A to B, that is the length of arc. So length of arc L is equals to
Or
2 pi r theta divided by 360. This is the formula. Using this formula, anytime we can calculate the length of any arc of a circle, but to calculate this, we must know what is theta and what is the radius of the circle. It depends on these two factors. Clear?
Right. In
Now,
the books, it
yeah.
says the arc length is radius times theta.
So, look, you know, if we measure our angle, this is the case when we have measured our angle in degree. This is the case when we have measured our angle in degree. I should write it so that no confusion is there.
That's in degree.
Yeah. So this is the formula.
So the one that I said is degree.
Listen, when theta is in degrees, then we use this formula. Okay. Fine. But what if when theta is in radians?
Okay.
When theta is in radians, you know, 2 pi is equals to 360 degree, or I
Yes.
can also write like this, that 360 degree is equals to 2 pi radians. If I want to convert everything in radians, then I will do it like this. L equals to 2 pi r theta divided by 360. 360 is actually equal to what? It's actually equal to 2 pi radians. You want everything in radians, so you will cancel them out and you will get this thing. L is equals to r theta. This formula will be used when your theta is in radians. So
Okay.
you should know both, because in exam we cannot guarantee that you will be given theta in radians or in
Yeah.
theta is in radians here. Okay.
Yes.
So now I move to the second thing. The second thing is the area of the circle. Sorry, not the circle, area of the sector. I'm redrawing the figure for you because that figure is not visible now. Here is our circle. Uh, we draw the oh, shit. We draw the sector here. We mark the center of the circle. These are the points A and B, and to cover from A to B, we have distanced an angle theta. So what we are going to calculate now? We are going to calculate area
Of sector.
of sector. Again, it will have two cases. One when theta is in degree, and the other one when theta is in
Radians.
radians. So I'm taking the first case when theta is in degree. Theta is in degrees. So it's clear that to cover the whole circle, if you start from A and you again reach at A and you cover the whole circle, if you cover the whole circle, then how much area you actually cover? That is pi r square. Area of circle is what?
Half.
Area of circle is what? Pi r square.
Yeah.
Okay, and to measure this area, you cover an angle of 360 degree. So that means 360 degree, when we move an angle of 360 degree, then we cover an area that is equals to pi r square. If we cover an angle of 1 degree, then we cover an area equal to pi r square by 360 degree. So to cover an angle that is equal to theta degree, then this should be equal to
Pi r squared theta.
pi r square theta upon 360. This is actually what? This is actually the area of sector. So we wrote here, we write here area of sector equals to pi r square theta upon 360 degree. Okay.
Yeah.
Now we want to calculate when theta is